Okay, this is 3 or 4.1. I'm going to do this without the PowerPoint. So for this one, to graph it, you're going to want to get it into slope-intercept form, or that's one way of doing it. So we're going to leave this, we're going to subtract 4x and subtract 4x, so we get negative 3y greater than negative 4x plus 6, and then we've got to divide by negative 3. So that gives us y. We divided by negative, so this has to flip. This becomes positive 4 over 3x minus 2. So our slope is 4/3. Our y-intercept is negative 2. We start at negative 2. We go up 4, 2, 3, 4 over 3. Up 4 over 3. And we're going to have a dotted line because this is not equal to. So when you see it like this, you're going to have a dotted line. When you see it like this, you'll use a solid line. So we need a dotted line. Now we have to decide which side of this to shade. So here it says y is less than. So we're going to go to the y-axis. This is less y's, so this is the side of the line that you would shade. That means that all of these are solutions. Any ordered pair that I pick in here is a solution. If it's on the line, it's not a solution because it's not equal to. Alright, this one says to graph using intercepts. So we're going to let x equals 0, and then we're going to let y equals 0. So if x is 0, 0 minus 2y greater than 5, divide by negative 2, divide by negative 2, so we get y, got to flip, is greater than negative 2.5. So we don't even need that right now. So y is negative 2.5. Now here's what we're looking at. If we let y equal 0, then x is 5. So we're going to graph these two. 0, negative 2.5, and x, or 5, 0. Let me get rid of this mess. Now, this says that it is less than, so we need a dotted line. And now we have to decide which one to shade. Here's y, and it says less than, but it's negative y. So that means we've got to flip it around so it says y greater than. So here's my y. These are my greater numbers. So this is the side we're going to shade. This is where all of my solutions are. Anything that's above this line, but not on the line. Alright, this is a system of inequalities. And this one, it's got our slope. It has our y-intercept. So 2, up 3 over 1. 1, 2, 3 over 1. And it is a dotted line. And it says y is less than. So we're going to shade this side. I'm going to use a different color. Alright, so this one we have a slope of -2 over 1 and a y-intercept of 3. So 1, 2, 3, -2 over 1, -2 over 1, over 1. It's a dotted line. And it says y is less than. So here's my y, here's my less, so we're shading this side. Now, if you see right here, down this broken line and down this broken line, in here are the solutions. So you can do it in 2 colors and then shade this in a 3rd color. You can go back and erase what's not the solution. Either way you want to leave it is fine. But we have to remember that we're going to say boundaries not included, because it's a dotted line. Boundary not included. So in here, if any ordered pair that's in here would become a solution to this system, but not on the lines. Alright. Number 4, graph using intercepts. Alright, so for this one, 3x minus 2y equals 5. So if x goes away, y is going to become -2.5. So we divide by -2, we divide by -2, 2.5. So 3x minus 2y greater or equal to 5. If y goes away, we divide by 3, and this is 5/3. So one of our lines is 0, -2.5, and 5/3 would be 1 and 2/3, so 1 about right here. And it is equal to, so it's a solid line. Alright, it says y, but it's negative, so we've got to flip it, so it's going to say y is less than, and this is our less numbers, so it's this side. So now let's do the next one. I'm going to do it in purple. So 2x plus y equals 8. 0, 0. If x goes away, y equals 8. If y goes away, x equals 4. So 0, 8, 6, 7, 8, about right here. And 4, 0, 1, 2, 3, 4. It's a solid line. And this says y is positive, so y is greater than. So here's y, here's greater, so it's this side of the line. Now let's graph x5. Bux, B-U-X, tells us that it is a vertical line. So 1, 2, 3, 4, 5. And it's a vertical solid line, so it's going up this way, this way. And this says x is less than. So here's x, this is less than, so we're shading on this side of the line. So it's a little bit hard to see, but if you look right here, right here, right here, is where all 3 of them touch. So the green is where our solutions are. And here we would say the boundary is included because it's a solid line. This boundary is included because it is a solid line. This boundary is included because it is a solid line. So any ordered pair inside here would make this system true. So this one asks us to graph this. So if I'm going to do this one first. If x is 0, y is 5. If y is 0, x is 10. So we'll do this one. If x is 0, y is 14. If y is 0, x is 7. And this is x equals 0 and y equals 0. So I'm going to do y equals 0. Start over. I am going to say that this point right here is 0, 0. And so my axis is here and my axis is here. And if I do this is a vertical line that goes through 0, so it's this way. It's hard to draw. And then this one I'll do in yellow is this way. This says x is greater than, so that would be on this side. It would be going, would be going this side. This says y is greater than 0. Y is greater than, so we'll be going up on the line. Then 0, 5 would be 1, 2, 3, 4, 5 right here. And 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a solid line. And it says y is less than, so we're talking this side of the line. And then 0, 5 again. 0, 14, so that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And 7, 0, 1, 2, 3, 4, 5, 6, 7. And it's a solid line. And then we have y is less than, so we're talking this side of the line. So in here is where it's all shaded. It says list the corners. Well, here's one corner, that's 0, 0. Here's one corner, that's 5, 0. 0, 5. Here's a corner where they meet, and that's 6, 7, 0. And then we have this corner right here, which we can't really tell, but we know that it is the intersection of these. So if we make this into a matrix, 1, 2, 2, 1, 10, 14, and we RREF it, then we can quickly find what the ordered pair would be. So I'm going to pause this so I can RREF it before I run out of time. So I can see from when I RREF'd this matrix, I get x equals 6 and y equals 2. And that's 1, 2, 3, 4, 5, 6, 1, 2. It's very close to that. So yes, this would be the ordered pair. That's the end of this problem, but very soon we go on and use this for something else. So I will make a video for that last question or two.